About 30 years ago, we had no scientific evidence of the existence of planets outside our solar system. Today, thanks to technological advances in scientific research, we've discovered over 5,300 exoplanets, alien worlds that are out there, waiting to be explored. Initially, these discoveries mainly involved large gas giants. However, as our capabilities expanded, we began to discover smaller, Earth-like exoplanets. Scientists have found more than 50 exoplanets with masses similar to Earth's and more than 800 worlds with a radius less than half the radius of Earth. We still know of very few planets that orbit in the habitable zone of their parent stars, where conditions are ideal for sustaining life. However, this is starting to change. As we continue our search for habitable planets, we are beginning to discover entire planetary systems with more than one potentially habitable world. We already know of at least one such system in our cosmic neighborhood. Our galaxy, the Milky Way, is home to countless compact systems orbiting stars similar to our Sun. However, planets orbiting very close to these stars are often very hot and therefore unsuitable to support life. However, when it comes to cooler, less bright stars, the habitable zone around them is much closer. An example of this is the Gliese 667 system, GJ 667, a triple star system located in the constellation of Scorpio, about 23 light-years from Earth. It contains the first known example of a system where a low-mass star has multiple potentially habitable rocky planets in its comfort zone. Like Alpha Centauri, this system has 3 stars. GJ 667a is a K-type main sequence star and the largest in the system. This orange-red dwarf has a mass equivalent to 73% of the mass of the Sun, a radius corresponding to 76% of the solar radius, and a visual luminosity of only about 12% compared to that of the Sun. About $12.50 away is its companion, GJ 667b. It is also an orange-red K-type dwarf, with about 69% of the Sun's mass and radiating only about 5% of our star's visual luminosity. And just like in Alpha Centauri, the third star is the most interesting. Gliese 667c is an M-type red dwarf with a mass and radius only 1/3 that of the Sun, mass 33% of the Sun, radius 34% of the Sun. It is also incredibly faint, luminosity 1.4% of the Sun, and a comparatively cool star, with a surface temperature of 3,775 Kelvin, Sun surface temperature 5,772 Kelvin. However, despite its small size, GJ 667c has a surprisingly rich planetary system. Initially, scientists thought there were only 3 exoplanets orbiting Gliese 667c, but after reviewing existing data and making additional observations, they discovered that there may actually be 6 planets in the planetary system, with 3 or even 4 of them being super-Earths. Potentially habitable. But what is a super-Earth anyway? The term is used to describe a planet that is larger than Earth, but not as big as gas giants like Jupiter and Saturn. These planets can be composed of rock or a mixture of rock and ice, and they can have atmospheres capable of supporting different forms of life. The closest planet to the star, Gliese 667cb, is an extremely hot world, with a temperature of approximately 200 degrees Celsius 392 degrees Fahrenheit. Being the most massive in the system, at about 5.5 times the mass of Earth, this exoplanet likely has a very dense atmosphere and orbits its host star in just 7 days. The 3 potentially habitable planets in the Gliese 667 system are all located farthest from their host star, and all have masses between 1 and 5 times that of Earth, making them prime candidates for habitability. Gliese 667cc, the next closest planet, orbits at the inner edge of the star's habitable zone. It has a mass about 3.8 times that of Earth and a radius 1.8 times that of Earth, and its year is only 28 Earth days. With an Earth similarity index of 0.85, it is known as the Holy Grail of extrasolar planets. Gliese 667cc is a planet beyond our solar system that orbits in the habitable zone around the red dwarf star Gliese 667c. Due to its proximity to the star, the planet is likely to be in a configuration known as tidal lock, where one side always faces the star, eternal day, and the other side remains in constant darkness, eternal night. This proximity results in extreme temperature differences between the 2 sides, which likely influences the exoplanet's global climate. Gliese 667cc receives about 10% less light than Earth receives from the Sun. However, most of the light that reaches this planet is in the form of infrared radiation, which means that it receives a similar amount of energy as the Earth. This could help retain water on its surface and result in an Earth-like climate if the planet has a similar atmosphere. Living in Gliese 667cc would be a very different experience than what we are used to. The planet would be bathed in a faint reddish light from its star, and the other two stars in the system, Gliese 667a and b, would be seen as a pair of bright stars visible during the day and would shine as brightly as the full moon during the night. Our Sun would be just a distant star. However, there are challenges to life on Gliese 667cc. The red dwarf star emits intense bursts of radiation and energetic particles, which could be harmful to any life on the planet's surface. In addition, the strong magnetosphere of the red dwarf can cause stellar activities that reduce the energy emitted by the star by up to 40%, together with the lack of ultraviolet light emissions, which can hinder the formation of life as we know it. The planet is also more massive than Earth, which means that the gravitational acceleration on its surface would be about 60% greater than on Earth. This would result in a person weighing more on Gliese 667cc compared to Earth. Furthermore, a more massive planet may have a denser atmosphere, which would lead to higher atmospheric pressure on its surface. Despite being in the habitable zone, Gliese 667cc may not have exactly the same conditions as Earth. Life forms on Gliese 667cc would have to adapt to dim and changing light, the possibility of high atmospheric pressure, and frequent solar flares. However, that doesn't mean that life can't arise on such a world, especially considering the remarkable adaptability we observe in life here on Earth. In addition to Gliese 667cc, there are two other potentially habitable exoplanets in the system, Gliese 667su and Gliese 667cf. Although they are located further away from their host star, they receive less energy, which could make them too cold to support life as we know it. However, if these planets have a dense atmosphere, it could help to trap heat and maintain favorable temperature conditions. The discovery of densely populated planetary systems around red dwarf stars such as Gliese 667c suggests the existence of many promising planetary systems, each with several potentially habitable planets. With advances in telescope technology, our ability to unlock the mysteries of the universe is growing exponentially, and we can look forward to more and more exciting discoveries about exoplanets and their potential for habitability. Which star system would you like to visit next? Leave your opinion in the comments. Stay tuned to be the first to hear about the next big discoveries in the cosmos, and don't forget to hit the thank you button if you enjoyed the video. Thanks for watching.